Hello all, welcome to Endurance Engineering Academy. So I am going to discuss few questions which is asked in GATE XC, XCB, okay, that is fluid mechanics from GATE 2021, okay. So this question has been asked in GATE XC in 2021, so let us read it and then we will solve it, okay. So in a Cartesian coordinate system, a steady incompressible velocity field. So they are given it is steady and also they clearly mention it is incompressible, okay, of a Newtonian fluid is given. So they said it is Newtonian fluid also, and also they given the velocity field. Now the first thing to notice in this velocity field is this is the complete velocity vector as they mentioned there, and I is the unit vector in x direction. So they given only, or indeed here this is going to be only one dimensional flow. There is going to be only change, that is velocity is going to change only with respect to y, and that too this is not y direction velocity, right, to be noted. This is u, okay. U is what? Velocity in x direction, okay. So velocity in x direction is given as this, and here this velocity in x direction is a function of y, okay. So let us keep it there. Now they mentioned A is a positive real constant and mu is a viscosity of the fluid. Since they mentioned mu, this is a viscous flow, this is not a non-viscous flow, okay. And they are asking absolute value of the pressure gradient. See, the first clue which is lying in the question is viscous flow. Yes, of course those two are also clue, but majorly this question has one important clue, that mu is viscosity of the fluid. They mentioned the mu value which clearly indicates that this is a viscous flow, okay. Since it is a viscous flow, we cannot use Euler's equation. They are asking pressure gradient, okay. If they are asking pressure gradient, your mind might think about what is that, Euler's equation, but we already know that for GATE XC, Navier Stokes equation is also there in the syllabus, and they mentioned viscosity of the flow, viscosity of the fluid, which means the flow is going to be viscous. So I need to use Navier Stokes equation only, and moreover they mention it is incompressible, and also they mention it is Newtonian, okay. So we can use the incompressible Newtonian fluid equation of Navier Stokes, and that is this, okay. So these are the three equations, Navier Stokes equation for an incompressible flow field, okay. Now the one misconception, okay, one misconception, if you not understood the concept properly, they given steady, okay, they given steady, okay, this is the first mistake. They given steady. Can I take du by dt, dv by dt, dw by dt as 0? Can I do that since they given it as steady? No. Acceleration of the fluid particle it's going to depend on, or it has two different component. One is convective component and another one is local or temporal component, which means acceleration of the fluid particle depends both on space and also on time. So if I expand this is a material derivative, right, or a total derivative. If I expand this, it will have a temporal component, so that will become 0 obviously because they given steady. But the component, the convective component which depends on space, that is not going to become 0. So this is the first silly mistake I could say, or a blunder, a conceptual blunder. If you not understood about material derivative, then it's a conceptual blunder, okay. Right, now coming to these three equations, okay. I could have written this equation in a simple vector form, but let it be. I want to say some more points related to these three equations, right. To first start with du by dt, okay. So we have u. So this is not going to become 0, convective component will be there, temporal component will be 0, no issues. Rho gx, body force, right? Did they talk anything about body force in this question regarding gravity or body force in any direction? Nothing. Now check the option. Is the option related with the body force? No, right? So the option is, there is no body force involved here, which means gravity is not included here, okay. You might ask me a question, sir, you can consider gravity in x direction, that is acceleration due to gravity in x direction, to be 0. They didn't mention that x direction is horizontal or x direction is vertical. They didn't mention it, right? They just said that what is that? Unit vector in x direction. It may be that x direction is vertical, or it may be that x direction is what is that? Perpendicular to the board or away from the board. There is a possibility. So that is why I am checking the option. They didn't state anything about body force, which clearly means that we can neglect all the body forces. Okay. If there was anything mentioned in the body force, for example, they are saying that y is vertical direction or x is horizontal direction, consider body force in y direction as gy, something like that, or even in the options also, if it is something related to body force, then we need to include it. So as of now, nothing, they didn't state anything about body force in the question, nothing in the options also, so we can neglect the body force, that is gravitational component in all the three directions, because they are not mentioning it anything, right? Like they didn't say that vertical or horizontal or towards the board or away from the board, so we are neglecting the body force, it is 0. Dou p by dou x, obviously that is what they are asking, pressure gradient, mu into dou u by dou x. Now u is a function of y alone, okay, u is a function of y alone, so obviously if I differentiate with respect to x, this will become 0. U is a function of y, so I can differentiate. Again, u is a function of y alone, so if I differentiate with z, that also becomes 0. Now coming for the second case, du by dt, sorry, dv by dt. Was there any component, y component, velocity component is given? No, our velocity vector consists of only u, okay, only x component, so this also becomes 0. Rho into gy, see, let me come for it later, okay, let me come for it later. Dou p by dou y will be there. What about dou u, dou square u by dou x square, dou square v by dou y square, dou square v by dou z square? Obviously 0, because there is no velocity component given in y direction, so we can take all 0. Now why I said to hold here? Okay, the simple fact, suppose in the question, somewhere in the question, they are mentioning that consider body forces in y direction as g. For example, consider body forces in y direction as g, or consider body forces in y direction as 10 or 9.8 or something like that. If it is mentioned in the question, then I need to include here. If I include that, then my answer will also get varied. Okay, I hope you are understanding what I am saying, but now they didn't mention anything, so well and good, no issues, it will become 0. So what actually it is indicating? Pressure gradient in y direction is, that is, yeah, pressure gradient in y direction is 0. Okay, dou p by dou y is 0. Clear, right? I hope it is clear now. Now coming for the third one, dw by dt, straightforward, simple, I am not wasting any time here, so it is 0. Rho g z, what happens here? If they are mentioning anything, then you need to consider. In this question it is not mentioned, but there is a possibility for mentioning. Either they will be giving you a clue in the option, that is they will include g in the option, or they will give in the question itself, but this question is somewhat straightforward only, so this is also 0, and there is no w component, so this is also 0, this is also 0, this is also 0. So now from this I could say dou p by dou z is 0. So p is not a function of y, p is not a function of z, so then p should be only function of x. Am I right? P is not a function of y, because dou p by dou y is 0, dou p by dou z is 0, so p is not a function of z, so p should be function of only x. Okay, so as p is function of only x, instead of writing it as, what is that, partial derivative, I can write it as, what I can partial derivative, I can write it as a normal derivative, that is I am writing this first equation. So instead of dou p by dou x, I can write it as dp by dx, and this is what we need to find out. Suppose they given, let me discuss at the end. First let me finish this. Okay, dou p by dou x, dp by dx plus, that is mu into dou square u by dou y square. So 2 times you have to differentiate this. What happens if I differentiate 1 time? See, I can use d here again. Why? Because u is a function of only y, so instead of dou I can use d, no issues. So du by dy, what happens? This will be u naught into 1 becomes 0 anyways, a into 2 times of y. Okay, if I differentiate it again, what happens? U naught into, this becomes minus a into 2, because y becomes 1 here. So simple differentiation. Okay, now here I'm substituting it 2 times of minus au, right? Sorry, 2 times of au naught. Okay, well and good. Now here, what about du by this du by dt, that is material derivative into normal form. This is our convective, what is that? Convective acceleration. This is our local or temporal acceleration. Already we know that it is steady, so this becomes 0, right? And v is already 0, w is already 0, right? Am I right? There is no v component given, there is no w component given, so v will be 0, w will be 0, so this is 0, this is 0. Now, u is a function of y alone, so if I differentiate with x, what happens? It also becomes 0. See, initially I asked a question whether this du by dt will be 0 or not. That time I said it is not, but here it is becoming 0. Why I said it is not? Because you cannot conclude that it is 0 from this statement. Okay, this is not becoming this total term, that is du by dt, is not becoming 0 because of this statement. It is not becoming 0 because of this statement steady. It is becoming 0 because of calculations, right? V is 0, so this term is 0, w is 0, this term is 0. If I differentiate u with x, since u is function of y alone, this is 0. So overall now everything is becoming 0, but you cannot conclude it directly that du by dt is 0 from steady. Okay, if it is steady, this is only thing which is going to become 0. These 3 terms are becoming 0 because of the given velocity profile. Simple. Now what we have, so dp by, I forgot the minus sign, I'm very sorry, minus dp by dx, and let me bring this to that side. So what happens, 2 mu a u naught, right? 2 mu a u naught. Of course, this negative sign, we know that as in the direction of flow in x direction, pressure is decreasing, so only negative sign. If you want to take that to other side, you can take, so dp by dx will be minus 2 mu a into u naught. So they are asking absolute value, so neglect the negative sign. So the answer will be option B, 2a mu into u naught. Okay, now let us consider that in the question they mentioned, what is that, g. Okay, they mentioned g is acceleration in y direction. Then what will happen? This will become g, right? This will become g. So which will be something like, I am extending the question. Okay, this question, the question asked in GATE 2021 is solved. So we got 2a mu into u naught. If I extend it, suppose they are mentioning g is acceleration in y direction, then what will happen here? This will become dou p by dou y will be equal to minus rho g. So we will have 2. Okay, so dou p by dou x will be this, dou p by dou y will be that. So what I need to do? Simple. I need to find out square plus square, that will give me the pressure gradient, that is dou p by dou x square plus dou p by dou y square. You substitute this here, you substitute this minus rho g here, take a square root, that will give me the delta p. Okay, that will give me the absolute value of the pressure gradient. In option also they didn't include body force, in question also they didn't stated body force, so I neglected the body force. But there is a possibility for twisting like that. There is a possibility they will give g value like this, and if they does, then there is a possibility that only this will also be there in the option. Okay, or only this will also be there in the option. But the actual answer should be the resultant of this two. You should not take this alone or that alone. Okay, in fact it will be something like, let me write it down here, like delta p will be equal to dou p by dou x I plus dou p by dou y j plus dou p by dou z k. And if you want to find out the magnitude alone, then what you will be doing? Simply I will be taking from our basic knowledge of vector calculus, right, or vector algebra. This is not even a calculus. Dou p by dou x whole square plus dou p by dou y whole square plus dou p by dou z whole square. And in this particular case, they didn't given body force, they didn't given u direction, v direction velocity, w direction velocity. So this has become 0 and this also has become 0. So only we had this. So root of dou p by dou x whole square. So it is dou p by dou x. That's it.